Do you need to move a semi-truck full of disk storage? Well, if so, AWS has you covered. That's right, AWS Snowball will deliver a truck to your door. But for most enterprise applications, you can get the job done in the cloud. In this course, you'll learn the ins and outs of object storage and lifecycle management in S3. Schema migration, backup, and replication of relational data in RDS. Experience flexible network file storage with EFS, and even move and transform data with AWS Glue. Hi, I'm Brandon Rich. I'm an enterprise architect at the University of Notre Dame. I've been working in the cloud since 2014, when our organization began a massive migration of services, business processes, and data to the cloud with Amazon Web Services. In the process, we learned a tremendous amount and became a recognized leader in cloud operations for the higher education space. Now, let's get started. If you're looking to store and manage data in the cloud, you've come to the right place. Amazon Web Services is home to a wide array of options to suit just about any data storage job you can throw at it, from file storage to relational data to NoSQL-style documents and objects. In AWS, you have many options as to the kind of storage available to you. There's object storage supported by S3, Amazon's oldest and most durable service. Block storage via Elastic Block Store, the easy way to provision drive capacity for EC2 instances. Relational databases, courtesy of RDS, Amazon's managed relational database service. You have NoSQL, courtesy of DynamoDB, and data warehousing via Redshift, though the last one is outside the scope of this course. When you use AWS storage and data management services, not only do you gain access to all these storage types in one place, but you also take advantage of AWS's high level of service and reliability. You get incredible durability, particularly with objects stored in S3. High availability, a built-in feature of many AWS storage services. Automated backups, automated as with RDS relational databases, or able to be automated, as with Dynamo or EBS. Managed services, where we don't have to worry about running the underlying servers or configuring and maintaining platforms. And seamless encryption at rest, as seen in S3, EBS, and more. Think of the time, research, and resources that can go into making your own homegrown or on-premises storage achieve these features, and you'll start to see why cloud storage, particularly in AWS, is so compelling. I do want to give a heads up about which AWS services are not in scope for this series. The data analytics tools, such as Elastic MapReduce, Kinesis, and QuickSight, are not discussed. If you check the details for this course, you'll see a link to a GitHub repository that contains all of the files that I'll be referencing throughout the course. Now, it's certainly possible for you to just listen, watch, and follow along, but if you want to go along with me and perform the demos yourself, these files will come in handy. Chapter 2 has a few data files that we'll use to interact with S3, as well as a policy template that we'll use to set up an SNS topic. Chapter 4 has some SQL code that we'll use to set up data in an RDS database, and a JSON file that we'll use for DynamoDB. Chapter 5 has a subfolder full of files that we'll use to demonstrate the S3 CLI, and a policy that we'll use to set up AWS Transfer for SFTP. Finally, Chapter 6 contains some SQL and some Python that we'll use while demonstrating AWS Glue. So whether you clone this repo or you're just downloading or referencing files from the web, everything you need should be here to follow along with this course. Let's get started. Your business or organization both depends on and generates data. Product orders, government records, student transcripts, emails, project documents, even chat logs. Though it's no longer paper, that data we create still piles up, and quickly, causing genuine risk for organizations whose operations depend on their data. How do we make sure that we can access the data we need when we need it, while at the same time minimizing storage and maintenance costs? That effort is called Data Lifecycle Management, the act of devising and implementing policies to control data as it flows through your organization. What is the data lifecycle? Well, there are a number of definitions out there, but in short, it's a bit like the water cycle. Data progresses from inception to active usage to archive, and from there either deleted for good or back into active usage. So when we talk about data lifecycle management, what we mean is enacting policies to migrate data to different tiers of storage as it progresses through that lifecycle. As your data usage goes from frequent to rarely used, it can move from faster storage to slower storage, and thus from more expensive services to cheaper ones. This process can be automated, letting data migrate tiers as policies such as age or access patterns dictate. As we'll later see, S3 has built-in mechanisms for doing just that. Key to ensuring your organization's security and compliance in the cloud is what AWS calls the shared responsibility model. The way AWS puts it The shared responsibility model means that AWS handles the security of the cloud, while the AWS customer handles security in the cloud. What this means is that AWS provides assurances about the security and capabilities of their services and about the physical security of the hardware on which your resources live. Meanwhile, you are responsible for understanding how to use these services in an appropriate way to satisfy your obligations. Let's start with security of the cloud. How can we be assured that AWS is doing all they can and should be doing on their side of the shared responsibility model? This might be a good time to look at some of AWS's security protocols. AWS states that their data centers are housed in nondescript buildings. They're secured at both the perimeter and at the facility itself. The security includes video cameras, security personnel, and more. Amazon also states that people wishing to access the data center floor must present multi-factor authentication at least twice. This ensures that the people entering the facility are guaranteed to be who they say they are. Anyone who gets this far is also accompanied constantly by security staff. Not only that, but AWS background checks all their employees, limits access to only those people with a legitimate business need for such access, and logs every visit to a remote location. All this should give you some assurance that no unauthorized person is going to tamper with the hardware running your EC2 instance or storing your S3 data. But what about other threats? AWS goes to extreme measures to protect against fire and flood. They build their own power supplies and back everything up with on-site generators. And of course, their data centers themselves are redundant and geographically separated. The multiple facilities that make up an availability zone are close enough to provide minimal latency for load-balanced or distributed workloads, but far enough away that a threat to one does not put the other at risk. This is, of course, why AWS always recommends replicating data and compute across multiple AZs. That's another part of the shared responsibility model. Shared responsibility extends not only to security, but to redundancy and availability as well. While some services, like EFS, handle replication for you, other AWS services leave it to you. If you don't architect your applications and data storage to take advantage of the high availability options AWS offers, you may end up putting your business at risk. That's just the tip of the iceberg as far as AWS's security of the cloud. Within the data centers of AWS, you'll find state-of-the-art advanced networking monitoring, world-class intrusion detection, strict change management practices, and regular third-party audits to ensure the solidity of all the above. If you're interested in the details, just search for AWS Security White Paper, and you can read pages upon pages of detailed assurances about the security of AWS. Suffice it to say that AWS spends more time, money, people, and effort on security and operations than most organizations could ever dream to match. Consider that when you're wondering if your data will be safer on-premises than in the cloud. So, what about security in the cloud? What's your responsibility? Well, it comes down to understanding your requirements, the capabilities of AWS, and how to properly configure each AWS service to match those requirements. For instance, RDS, the relational database service, provides an option for replicating across availability zones, but you must enable it yourself. If you don't, and the single instance of the RDS database is lost or compromised, AWS will not be able to do anything about it. Similarly, Elastic Block Storage, or EBS, allows your data volumes to persist after a host terminates, and to be snapshotted and backed up at will. However, if you don't enable those settings to take advantage of those features, their usefulness will be nil in a disaster scenario. S3 is a perfectly safe place to store data, but AWS will not stop you if you choose to set a security policy that makes it public. And encryption works the same way. EBS, S3, and EFS all offer seamless server. Depending on your particular industry, you may be obligated to demonstrate compliance with any number of regulations regarding data movement and storage. A few examples include PCI DSS for the handling of financial information, HIPAA and high-tech for health information, and FERPA for the handling of educational records. Some IT professionals and even CIOs may fear that moving data to the cloud may put their ability to comply with regulations at risk. If that sounds familiar, fear not. AWS goes to great lengths to make sure that whatever your legal requirements, you can work with AWS to ensure compliance and take full advantage of all the cloud has to offer. AWS provides detailed guidance regarding many different regulatory frameworks. If you go to aws.amazon.com/compliance, you can drill down into any number of regulations and find out more. If we scroll to the bottom of this page and click the link Compliance Resources, We'll find a list of white papers that AWS provides to help you understand how to do compliance in the cloud. For instance, Architecting for HIPAA Security and Compliance on Amazon Web Services. Clicking that opens a PDF. All this content used to be exclusively provided by PDF, but now we see a link here that takes us to a web version of the content. You want to pay particular attention to this section. Each of the documents of this kind provides details on which AWS services are suitable for keeping that kind of compliant data. It'll even tell you which features within individual services you should avoid or specifically configure to stay within the law. In fact, AWS devotes an entire section of its web console to keeping you aware of compliance matters and security of the cloud. It's called AWS Artifact. Here I am at the main console of Amazon Web Services. You access AWS Artifact the same way you'd access any AWS service, such as EC2 or RDS. It's an entry in the main menu. So I'll click Artifact here, and then choose View Reports. Inside, we'll find a list of documentation that AWS makes available related to its own compliance status. You'll find ISO reports, PCI DSS, SOC reports, and more. When you choose to download one of these documents, your copy will be watermarked with a special code identifying you as the original requester, so don't share your copy. Because of this, I won't demonstrate downloading the documents, but I will give you one word of advice. Use Acrobat Reader to open it. The documents come in a special format, where the main document is a set of terms and conditions, while the actual content you're after is an attachment to that. The text provides some instructions on how to access the content with Adobe Acrobat Reader, but if you're using something like Preview on the Mac, it may not be clear how to reach the content. Of course, some regulatory frameworks are stricter than others. If you're a government or higher ed institution subject to ITAR, FedRAMP, or SRG, you may want to look at GovCloud. To find out more, we'll go to aws.amazon.com/govcloudus. GovCloud is an entirely distinct region of AWS that is in many ways identical to other regions like Virginia's US East 1, except that GovCloud is 100% housed within the US and accessible only by US citizens. GovCloud has a provisional ATO, or authority to operate, under the FedRAMP high baseline. These are crucial features for organizations subject to ITAR or US international traffic in arms regulations. Customers must create and maintain a fully separate account for GovCloud, distinct from any other AWS accounts they might operate, and they must sign a GovCloud-specific contract. They must be, quoting AWS documents now, U.S. persons not subject to export restrictions and who comply with U.S. export control laws and regulations. Organizations must apply for GovCloud from an existing account or through an AWS business representative. If your organization launched way back in March of 2006, S3, or Simple Storage Service, is one of Amazon's longest-running AWS offerings. Its purpose is to provide easy-to-use cloud storage that is scalable, highly available, and reliable. Before we start, it's important to note that S3 isn't actually a file system in the traditional sense. Rather, S3 provides what's known as object storage. What distinguishes object storage from file storage? Well, storage devices come in a few flavors, having to do with the level at which the storage system manages data. Block storage operates at the level of disk blocks and sectors. This is the lowest level to the hardware. Sectors originally referred to actual sectors on the circular magnetic disks and platter-based hard drives. In the age of solid-state drives, sectors are more of a logical construct, but the concept remains the same. Block storage is generic and can be formatted to apply a file system on top of it. File storage is what you're probably most familiar with. A file storage device uses a file system, software that manages files in directory structures, sometimes with permission bits that describe who can read, write, and list the files. Examples include FAT32 and NTFS for Windows, HFS for Mac, and ext4 for Linux-based systems. Object storage is a bit different. An object might be a file from your computer or server's file system, but once placed into object storage, it's an object, data with metadata attached. In S3, this metadata often takes the form of tags, the same kind of tags that appear on resources throughout AWS. Objects go into buckets. A bucket is called that because you can basically throw anything you want in it. In a real-life bucket, there's no structure, there are no shelves. Likewise, an S3 bucket has no native concept of folders or hierarchies. It's all one flat namespace for objects inside. Of course, unlike a real bucket, S3 buckets can hold a virtually unlimited amount of objects. S3 can easily scale to hold billions of objects. It's also very important to understand that, unlike with a file system, your server can't natively mount object storage. Rather, your host will talk to S3 via RESTful APIs, through an SDK like the ones for Python or Java, or using some kind of abstraction layer. For instance, Ruby applications can use a gem called Fog to abstract S3 and treat it more like a file system. There are also hardware and software gateways that can provide this abstraction for an entire server, such as AWS's File Gateway. In the case of File Gateway, the middle layer actually does provide an NFS mount, so your instance can take advantage of S3 storage while still talking to a typical file system. Back to buckets. The namespace for buckets is global, which means that each time you create a bucket, you'll need to come up with a name that's unique worldwide. Object names within a bucket can contain letters, digits, or certain special characters, including slashes. Speaking of slashes, I said there's no concept of folders in object storage, and that's true. However, S3 goes a long way toward pretending that there is. Take a look at these two object names. Knowing about the flat namespace, you may recognize that these are just object names that happen to share some of the same characters. But S3 will visually represent them as two objects within a Files folder. This convenience is a bit confusing when you know the truth, but in practice it rarely causes issues. In fact, the folder metaphor runs pretty deep depending on which interface you use. These days the web console even has a Create Folder button, and it doesn't even let you set key names with embedded slashes. So, what distinguishes S3 from any other object storage? In the next video, we'll get into S3's incredible reliability, security, and data management features. Let's talk about S3's vaunted availability and durability. Availability refers to the S3 service itself. Will S3 respond when you make a request to store or retrieve an object? Durability refers to S3's ability to keep your data without corrupting it, or losing it. So here are the numbers. Objects stored in S3 are 99.99% available in standard storage mode. And as for durability, well, I'm not even going to try to say that, but it's 11 nines. AWS claims that with that level of reliability, if you were to store 10,000 objects in S3, you might lose one object every 10 million years. That's a level of certainty that goes well beyond that of any physical storage I've ever maintained myself, no matter how redundant. As for that availability, well, 99% uptime doesn't mean that S3 never goes down, but if it does, the service level agreement clock starts to tick down. If S3 is out for long enough, users will start to see refunds on their bill. This actually happened back in early 2017 when a misconfiguration caused S3 to go down for several hours. With so many customers, you can bet that this money-back guarantee provides AWS with plenty of motivation to keep their services up and running. Curiously, the wide array of services that suffered concurrent service interruptions, such as Slack, Trello, and many more, only serve to demonstrate how widely used and trusted S3 is as a cloud data storage provider. During that time, those companies weren't scrambling to restore service. They knew they could rely on AWS's world-class engineers to keep them informed and correct the problem. AWS offers multiple ways for you to secure your data in S3 with both client-side and server-side encryption. Once enabled, server-side encryption in S3 provides seamless encryption of data at rest. At rest means while the data is sitting in S3. Seamless means that the client doesn't even need to know about the encryption in order for it to work. Objects uploaded to S3 get encrypted before they're stored, while objects downloaded from S3 get decrypted before they're sent to you. When you create a bucket, you're offered three choices. You can encrypt with an S3 dedicated key that's specific to your account. It's auto-generated by AWS and shared with no one else. You can encrypt with a key of your own creation using KMS, AWS's key management service. KMS is a service that lets users generate encryption keys and helps with tasks like rotating and expiring them over time. Finally, you can encrypt with your own BYO key, which means client-side encryption. In this case, you'll handle encryption and decryption yourself before you pass data off to S3. In both server-side methods, S3 performs seamless encryption, meaning you don't have to worry about the details. You just pass data in and out, knowing it's encrypted while at rest. How about encryption in transit? Requests to and from S3 made through the AWS console are always encrypted via TLS. Requests using the AWS CLI are too. Any REST request is encrypted too, as long as it's made via HTTPS. If you make REST requests over plain HTTP, your data will not be encrypted in transit. S3 provides multiple different tiers of storage for different use cases. Within a single bucket, individual objects can exist in one of the following. Standard storage is the default. Highly durable, basic S3 storage. As you go down the tiers, storage becomes cheaper, but there are trade-offs. Infrequent access, standard, is essentially the same as S3 standard, but with fewer nines of availability guaranteed. Its durability is the same. Next, infrequent access, one zone, lets you trade a little more availability for cost. Unlike the first two S3 classes, objects stored at this tier are not replicated across 3 or more availability zones. They only exist in one, making them potentially vulnerable to an AZ outage, a rare event in itself. Finally, intelligent tiering watches your data usage patterns to automatically shift individual objects between storage tiers designed for frequent, infrequent, and rarely accessed data. Glacier, once its own distinct service, is the name for S3's multiple tiers of long-term archival storage. These storage classes give you the cheapest possible storage cost, as long as your access patterns are infrequent. Outside of cost, the main difference in the three is how often and how quickly you can retrieve data. Glacier Instant Retrieval can return data just as fast as standard S3, in milliseconds. Let's get started by creating an S3 bucket. Here I am at the main dashboard of Amazon Web Services, and before we go into the S3 specific section, I want to point out this dropdown, which for me currently says North Virginia, here in the top right. If I click it, you'll see a list of all the regions in which AWS operates. This dropdown exists on most screens in Amazon Web Services, and it's used to determine where the resources that you provision actually get created. When you have a region selected, that'll filter the view in most parts of AWS to show you just resources that exist in that region. So you could give yourself a shock by working in one region and changing regions and forgetting that you've changed it and wonder where all your resources have gone. So if that ever happens to you, just look up here and make sure that you're working in the region that you expect to be in. For purposes of this course, the best thing to do is just pick the region that's closest to you geographically, which for me is that North Virginia, and stick with it for the duration. Now we'll head into S3. I've recently visited that service, so it's right here in the top under Recently Visited. I can also click Services and see a categorized view of AWS. There's S3 right at the top, or I can search here by typing S3 and selecting the first option. If this is your first time into S3, you'll see a screen that looks like this. We can click Create Bucket. And here we are, ready to configure our first bucket. We need to give it a name, so I'll call this Demo Primary. And remember, S3 bucket names need to be globally unique, so I'm going to append my name here. And you should do the same. Now, let's take a look at this region dropdown because it looks a little different. It says Global, and all the regions are grayed out. S3 is one of the few places in AWS that acts a little differently from the rest. It says Global because when you look at a list of buckets in S3, it's going to show you buckets from every region. Now, S3 buckets do have a region, as you can see right here. We're going to select the region in which to create the bucket. Buckets are region specific. It's just that the S3 part of the console shows you everything at once. There's no filter. That's why it says global. So choose your region right here, make it the same one that you chose earlier to stick with for the duration of the course, and scroll on down. Under object ownership, you can keep the default recommended choice of ACLs disabled. If you choose the other option, that will let you set individual object level permissions, which is not what we are interested in for this demo. We'll keep the default, block all public access. We're going to be interacting with this bucket from and within AWS, so we won't need any public access. Bucket versioning we do want to enable. That'll let S3 keep track of changes to each individual object in the bucket. Under tags, this is optional, but we can add a tag. We get a key value pair input here, and this can be whatever we want. So I'm going to call this key Creator and put Brandon, so that anybody who looks at this bucket later will see that information and know who created the bucket. You can add more tags if you like. Sometimes these may just be informational for other users of this account, or in some cases, they could be used by third-party services or other add-ons that will take some action for you based on tags on resources in your account. Let's move on to encryption. This is disabled by default, but you can enable it, and you get two options. You can get Amazon S3 managed keys, which is the key that's created for your account by Amazon, managed by them, or you can choose KMS keys. If we were to choose the latter, we would need to have already created a KMS key in a different part of AWS, so we'll just stick with that first option. We don't need advanced settings, so we can just click Create Bucket. Okay, now we have our bucket created, and we can click into it. And we can see that we don't have any objects yet, so there's nothing under objects. We have a couple other tabs, including this properties one that has different options for us. You can see that we have versioning enabled. We can see the tags that we created. And if you scroll down, you can see this server access logging. This is something that I would like to enable. If we click Edit and enable that, you can see that we're going to be asked to give a different bucket for the logs to go into. So we actually need to back out of here because we don't have another bucket yet. So hit cancel, and you can actually click over here and go to buckets. And let's just create another bucket by clicking create bucket. We'll give it a different name. We'll call it demo logging. And again, I'll append my name there just for uniqueness. Keep all the other options at their default and click create bucket. By the way, very important on this logging bucket, don't enable versioning. That's just going to create a whole lot of versions as logs get written to this bucket. So here we have our two buckets, demo primary and demo logging. And we'll click into the primary bucket, go to properties, head down to server access logging, click edit, enable, and then browse S3 to choose our destination bucket, demo logging. Click choose path, and then we could from here just save changes, but there's one additional thing that I can do. You can see the prompt here that says prefix, and remember that if I use slashes in a prefix, S3 basically some objects to the bucket and see how this logging works. All right, now that we've got our bucket, let's click it and add some files to it. We can see on the screen that we've got a couple of tabs of different perspectives on the bucket that we'll explore in future videos, and we have no objects in the bucket. You can see the count here is 0, and we've got an upload button, so let's click it so that we can add some things. We've got the add files button, we'll click that. And if you look in the exercise files of this course, you'll see Chapter 2 has a few data sets that we can upload. These are obtained from data.gov, so just freely available for anybody to pick up. I've got one about Maryland farmland here, and we can also click the states.csv file and go ahead and say open. This will allow both of these files to be uploaded at once. If we look at properties, we can expand that, and we can see storage class, which you may now be realizing was not something that we selected at the bucket level. So every individual object in a bucket can have a different storage class. If you think back to the slides on object storage in S3, you'll remember some of these. We've got standard by default with its really good durability and availability. You've got standard IA here, which is infrequent access, so that trades a little bit of that availability for reduced cost. You've got intelligent tiering, which will move your data around to different tiers based on usage and access patterns. And of course, you've got the Glacier tiers as well. We'll leave these at standard for now and scroll on down. Server-side encryption. So we already selected this at the bucket level, and that'll take place for all the objects that go into the bucket, so we don't need to do anything here. Checksums are an optional feature that you can turn on a per object basis that will give you a hash that you can check over time with your reference that you keep to make sure that there's been no degradation in an individual object. That's a pretty rare event, but this is a useful feature for archivists and folks like that. Finally, we've got tags and metadata. You'll remember that we set tags at the bucket level to show who created the bucket. We can do the same here. We can add a tag, and we could put a creator tag here, or any other type of tag. You know, if these are all CSVs, we could say type is CSV. Anything that you might find useful. Metadata we've got here is similar but slightly different. It's the metadata that's actually attached directly to the object. This is different from tags in that metadata is something that you'll get anytime that you request an object, say from GET request through the API or an SDK request for the object, you'll see that metadata. Tags are like tags that exist throughout AWS. These key value pairs that can be pulled up by a dedicated API call that says, what are the tags on this resource? And one of the main differences is that tags, capital T tags, Another powerful feature of S3 is the ability to replicate automatically across regions. Now, we've already talked about how great the durability and availability of S3 is, so why would we want to replicate across regions? Well, first, it's not impossible for a region to have an outage. There have been a couple of examples of this occurring in the history of AWS. And so it can be a good safeguard to have things not just replicated across availability zones, but also across regions. It's a rare event, but it can occur. The other reason you might want cross-region replication is because, as I said before, you want to choose your region based on the proximity to the users or workload that would be accessing the S3 data. So if your workload is actually cross-region, say if you're a global organization, it might make sense to replicate your data across regions for performance purposes. So with that said, let's take a look at how to enable cross-region replication on our demo bucket. Before we do this, we're actually going to need a destination bucket in another region. So to do that, we'll go ahead and click Create Bucket. We'll give a name. We'll call it Demo Secondary Region, and then initials, just like before, to make the name unique. And we need to select an alternate region. I'm going to scroll down here, and I'm going to choose Ireland. Beautiful country, good place for our objects to go. And we'll go down and choose Versioning Enabled. Other than that, we'll leave all the options at default and click Create Bucket. Now that our destination bucket is created in the Ireland region, which you can see here, we need to click back into the primary bucket, which is called Demo Bucket. From here, we'll choose Management, then go down to Replication Rules and click Create Replication Rule. Now, we need to give this rule a name, so I'll call it Replicate to Ireland. And its status will be Enabled. If we go down, we see the source bucket and some options here to limit or filter the objects that get moved from the source bucket to the destination. So you have the option here if you wanted to, say, create different rules for different subsets of your data or just exclude some objects entirely for whatever reason, you can do that. But in this demo, we want everything to move over, so we'll leave things as they are at default. Scrolling down to destination, you want to click Browse S3 so we can choose our destination bucket. That's Demo Secondary here, and choose Path. All right, that's set. Let's go down to IAM role. Okay, so what is this all about? Well, in order to do the replication, AWS needs to act on your behalf. It needs to be able to take the objects out of the source bucket and replicate them across to the other bucket. So as you will see in plenty of places in AWS, the service itself needs to assume a role with permissions. So this is the same kind of role that you would give to a user, you're just giving it to the S3 service. Now you've got a couple of options here, including choose from existing IAM roles, and if I click on this, I will see there's an option that says create new role. And because I'm currently logged in as a user that can create IAM roles, that is a root user in this case, I can choose this option and this wizard will create that IAM role for me behind the scenes. So encryption we don't need to worry about. But destination storage class is interesting. If you click this, you'll find that you can change the storage class that objects get replicated into, so they can be something different from what they are in the primary bucket. If your replication was something that you thought maybe wouldn't be used very often, you could put it in a cheaper tier of storage so that you would save a little money that way. Of course, you're always making a choice between cost and your use case. There are a couple of advanced options here that we could touch on. Replication time control is something that gives you additional auditing and logging of your replication. It notifies you if an object fails to be replicated ever within 15 minutes. This can help you achieve some compliance goals with your S3 storage if that's a requirement for you. Delete marker replication is interesting. If your source bucket has versioning enabled, it never actually deletes anything. A delete action on an object is just like a change that gets recorded by the versioning over time. So instead of actually fully getting deleted, it gets a flag set on it, which S3 calls a delete marker. So the question here is whether that delete marker should get propagated over to the destination bucket. Since we want these buckets to look exactly the same, I'll go ahead and click that. Replica modification sync here is something similar for metadata on objects. So I'll click that too and choose Save. Then we get a question here, whether to replicate existing objects. And we'll say yes, because we want to go ahead and move those objects that are already in the bucket. Click Submit. Now we see this screen, Create Batch Operations Job. All that rule setup leads into this batch job that runs regularly to replicate the data from one region to another. You can see we've got an option here to automatically run the job when it's ready, which we would love for it to do, so we see these results immediately. You can get a completion report out of this job, but I'm going to uncheck that because I don't think we need to configure that right now. Let's go ahead and keep the rest of things at default and click Save. All right, now you can see that we have this job. If we click this refresh button, we should see the status that it's in. So it's trying to replicate the existing objects. It's in a preparing stage, and you can continue to monitor it by clicking this. Now in the future, this will be an ongoing task, so you won't ever have to kick this off again or sit there and watch it, but it will just happen on its own. All right, now the job's in ready state, so it's about to run. Now it's active. And after a few minutes, the job is in complete state. So you see it found 2 objects, 100% complete. We can click this hamburger menu over here, go back to Buckets, then click into the Ireland bucket demo secondary and see that those objects exist. If we want to take this a step further, we can go to Buckets, Another really powerful capability of S3 is the ability to send notifications to other AWS services when something happens in the bucket. You can send messages to SNS, the simple notification service, to SQS, the simple queue service, or to Lambda functions, where you can actually execute code in response to something changing in S3. For this demo, I'd like to set up an SNS topic and show you how to connect it to the S3 bucket to receive notifications via email when certain events occur. So here on the Home console, in the search bar, let's type SNS and choose the first option, Simple Notification Service. SNS is a pub/sub service. It lets you create message topics so that you can blast out notifications to subscribers via email or text messaging. Today, we'll set things up so that we get emails when things change in S3. So here we want to create a topic, and we'll call it S3 Demo Notifications. Click Next Step. You can see here that you have a couple of options for how this message topic works. Standard means at least once message delivery, which means there's a possibility of duplicates. So if that were a problem for your use case, you choose the first in, first out style. For us, standard works just fine. We've got our name. Display name is optional, so we can skip that. In fact, we can just scroll all the way down and click Create Topic without changing any of the defaults. Okay, now that the topic is created, we have one more step. With the pub sub model in SNS, you can have multiple subscribers to the one publisher that is the message topic. So right now, we don't have any subscribers. We need to create a subscription to this topic so that we can receive email whenever S3 has a notification for us. I'll click Create Subscription. The protocol here we'll choose will be email. And the address is an address I've created for purposes of receiving the mail. You should put your own address in here if you want to try it out. Click Create Subscription. Okay, now the subscription is created, but before I can start to receive emails, you can see we've got a status here of pending confirmation. That means I need to go into my email account and respond to a message that will ask me to confirm the subscription. So I've got this open in another tab here, and you can see I've got subscription confirmation here as an email, and all I need to do is click this link, and that will confirm my subscription, which means now we can go back into SNS, and if we refresh the page here, we ought to see that the status is updated, so now we're confirmed. We can click back to the topics list, go into S3 Demo Notifications, and we can test things out real quick. Click Publish Message, and we'll give a subject, just something like Hello World, and then some kind of message body here. Just say, this is a test message. Scroll down, and we'll click Publish Message. So this will allow us to confirm that we are receiving emails from the SNS topic. Here in my inbox, there we go, Hello World, test message. That is all working. But before we can have S3 start to send notifications to this topic, there's one more thing we need to do. We need to set an access policy on the topic that will specifically allow our demo bucket to publish events to it. If you're here in the topic and click Access Policy, you can see the current policy, but it's read-only. Head up to the Edit button here, and we'll be able to change it. Expand Access Policy, and you can see that this section is now editable. As for what goes in here, well, if you look in the Chapter 2 section of the exercise files associated with this course, you will see a document called SNS Publish Policy Template.json. If you copy this, we can fill in the values that will make this work. So copy, head back in here, erase what is already there, and paste the contents. Now, if you look here, you'll see that we're allowing the S3 service to publish to this SNS topic, and what we need to provide is the unique identifier for the S3 bucket, as well as the SNS topic. So from here, we need to open up some new tabs so we can keep this window open, but also go fetch those identifiers. The first thing to do is go up here to the name S3 Demo Notifications, right-click, and choose Open Link in New Tab. That will let us have the details of the topic here, and we can copy the ARN, that unique identifier, head back to the first tab, and paste that over the SNS topic ARN. So I'll erase that, paste that in. Now here on the second tab again, I will go type S3 to go to the S3 section, find our demo bucket, go to Properties, and copy its ARN. In this case, I can click the copy button, and that will go into my clipboard. Back here, I'll paste that over S3 bucket ARN. Make sure there are no additional spaces, and we're good. I'll go down and hit Save Changes. Okay, now that we've got the SNS topic all set up, in the next video, we'll head back to S3 and configure the event delivery that'll make this all work. Okay, following up from the previous video, we've got our SNS topic all created and ready to receive events from the S3 bucket. So now we just need to go configure that on the bucket itself. That demo bucket is still open here in the second tab, and it's open to the Properties section, which is where we need to be. Scroll on down to Event Notifications and click Create Event Notification. Here we need to think a little bit about what kinds of notifications we want to send from this bucket. For this demo, we'll send an email anytime something is deleted out of the bucket. Maybe we've got important files in there and we want a notification anytime that happens. So we'll call this S3 Deletion Event Notification. And we'll scroll down here to Event Types. This is where we can select all the types of events that we want to show up in our email whenever they happen. I'm interested in object removal. If I click Permanently Deleted or Delete Marker Created, that'll cover everything, but there's this all-encompassing section over here, if I check it, called All Object Removal Events, which encompasses both of these. So that'll be good, and I'll scroll on down to the bottom. The destination is an SNS topic, of course, and we need to choose our topic. Here in the drop-down, we see the one we just created, S3 Demo Notifications, and we can click Save Changes. Now, all we need to do to test this is to go to our Objects section and delete something. So I'll select this first one, Maryland. Let's talk S3 storage tiers and lifecycle policies. First up, we have S3's primary offering, S3 Standard. This general-purpose tier sports an amazing 11 nines of durability, which in fact, all S3 tiers do. It also has 4 nines of uptime, meaning that, on average, you might experience 1 minute of unresponsiveness a week. In practicality, the service is much more reliable than even that, as the advertised numbers take into account the effect of the rare actual service outage, wherein you might accumulate several minutes of downtime at once. To get a sense of the low cost of AWS object storage, this, most expensive S3 tier, will run you about 2.3 cents per gigabyte per month, with prices falling the more you store. So that's S3 Standard. From here, we'll be making trade-offs. Lower cost, but along with that, certain concessions in terms of things like uptime and speed of retrieval. Intelligent tiering is a storage class that can move data for you automatically by watching your access patterns. It charges a small amount to monitor your data, but then moves objects between frequent, infrequent, and archive instant access tiers without your intervention. It's worth noting that the tiers used by intelligent tiering are not technically the same as the other S3 tiers we're discussing in this video. This storage class kind of stands on its own and has its own internal tiers. You could basically think of this as an easy button for managing data lifecycles, but if you'd like a little more control over your object storage, you'll want to keep listening. The next two storage tiers trade a bit of availability for cost. The IA in Standard IA stands for Infrequent Access. If you don't need to get to your data all that often, give this tier a try. Do notice that at some point you run into some storage minimums. First, objects that are deleted before 30 days incur a small monetary penalty. Second, for billing purposes, each object is treated as if it were at least 128K. This is no doubt due to some internal quirk of storage allocation happening within AWS, but it's something to be aware of. One zone IA is just the same, but as the name suggests, limited to just one availability zone. That drops its uptime to 99.5%. To be clear, when your objects are stored in just one AZ, you're subject to losing access in the event of a full AZ outage, or losing your files if the AZ is somehow destroyed. Still, depending on your requirements, it might be a risk you're willing to take to achieve lower costs. For this tier, you're looking at about only 1 cent per gigabyte per month. Glacier is Amazon's long-term data archiving solution. It's designed to store vast quantities of data as reliably and cheaply as possible. There's literally no limit to the amount of data you can store, and a single archive file can be up to 40 terabytes in size. Of course, there's a trade-off for this low-cost reliability. As the Glacier name implies, to retrieve data you must effectively unfreeze it, and depending on the tier you choose, the process is not necessarily immediate. After all, the Glacier use case is for archival or long-term storage, for things you need to keep for, say, compliance purposes but don't need to access quickly or regularly. Glacier used to be a fully distinct service from S3, but eventually AWS simplified things quite a bit by making Glacier into a set of storage tiers of S3. Let's take a look at what those tiers are. First, there's Glacier Instant Retrieval. This is where the prices really start to drop at 0.4 cents per gigabyte per month. However, you now have a minimum of 90 days that you must keep data stored before retrieving it. Still, when you need the files out of here, you can get them instantly. Price drops even more with Glacier Flexible Retrieval. In this case, the flexible party would be you. If you don't mind waiting minutes to hours for your data to become available to re-download, this tier is a great option. Now the per-object minimum size changes to 40K. Finally, the longest-term, cheapest archival storage on AWS, Glacier Deep Archive. Retrieval takes hours, and you must keep objects a minimum of 180 days, but the price is less than 0.1 cent per gigabyte per month. That low-cost storage is no doubt attractive, but of course often you won't want to archive data directly to Glacier. Rather, you'll be starting with hot data, data that is frequently accessed. What you'd like to do is migrate it over time, as it becomes less frequently used, to cheaper long-term storage. S3 lifecycle rules allow you the control to do exactly that. S3 lifecycle rules can migrate data to cheaper storage tiers in S3. They're based on object age in days. Now let's see how we can configure S3 to manage the data lifecycle of the objects in our bucket. Go ahead and click into your demo bucket, and then to the Management tab. Here you see Lifecycle Rules, and we'll create a new rule by clicking this button, Create Lifecycle Rule. On this screen, we have a lot of flexibility as to what we can do, and as to how much logic we can put into a single rule. But we want things to be readable and easy to understand, so we're going to do these things in a few steps. The idea here is that we're going to tell our objects to go to infrequent access after 30 days, then go to the Glacier tier after a longer period of time, and finally, after a year, expire and delete completely. So to do that, like I said, we could put it all in one rule, but for readability's sake, I think for better maintainability, sometimes it's nice to have them separated. So we're going to start with a rule called Move to Infrequent Access. Now this next section, like we've seen in other parts of S3, asks whether we want to scope this rule down to any subset of objects. We don't want that, so we can leave this all at default, except in this case, the default selection is to limit the scope. So we need to select this radio button here that says Apply to all objects in the bucket. S3 gives us a little bit of a warning, and we just need to say, yes, we understand what's happening, we know what we're doing. We acknowledge and move on. All right, here's where all the logic gets defined under Lifecycle Rule Actions. We're going to act on both current and non-current versions of objects in the bucket. Because remember, we're dealing with a bucket that we set to be versioned. So it has both current versions and past versions of any edits that we've made over time. So this move to infrequent access, we're going to make very straightforward. We're just going to apply to every version of every object. So we'll check both of these. Move current versions of objects between storage classes, yes. And move non-current versions of objects between storage classes, also yes. That results in two configuration boxes down below, which we will now edit. So we're going to move current versions of objects to standard infrequent access after a certain number of days. And in fact, you can see as we're typing that 30 is the minimum. So we're just going to go with that. That fits nicely. 30 days, you can see we can add more transitions, move things to other tiers in this same rule after a different number of days. That's perfectly viable, but we're going to keep things straightforward, so just have the one rule. Non-current versions, we're going to make no distinction here. We're also going to move those to infrequent access after the same number of days, 30 days. You can retain some number of past versions here if you want. Just leave this blank though, and we'll move on. You see a summary of what's going to happen as a result of this rule on the last part of the screen here. Just make sure that looks good, and we'll say create rule. All right, so that's the first part, move to infrequent access. Let's click the button to create another rule, create lifecycle rule. This is going to be move to Glacier. Same thing, apply to all objects in the bucket, acknowledge this is what we mean, and we're going to move current versions and move non-current versions. This time not to IA, but to Glacier Flexible Retrieval. This time, we'll move it after 100 days. There's a note here where S3 is warning you about the retrieval cost of objects in Glacier. We know about that, but make sure to read if you want more details. And click Acknowledge. Same thing for the non-current versions. Go to Glacier Flexible Retrieval. After 100 days, leave this blank, no need to retain any objects. By the way, if you put a 0 in here, you may see an error, so do just leave that blank. Acknowledge the warning down below, read the summary, and click Create Rule. Okay, so that's step 2 of 3. We'll create one more. This is expire objects. We'll apply to all objects in the bucket, acknowledge the warning, and this time we won't select these two first checkboxes. Instead, we'll go to expire current versions and permanently delete non-current versions. Again, this is not a very sophisticated rule. You may want to do different things in your bucket depending on your use case. But for current versions, after a number of days of object creation, we're going to say 365 there. As for non-current versions of objects, same thing, 365. And we will not retain any past versions. So this will delete everything, current and non-current versions of objects after a year. We'll click Create Rule. So with that, we've established a complete data lifecycle policy for the objects in this bucket. After 30 days, they're going to move to the cheaper infrequent access tier. After 100 days, they're going to move to Glacier. And then after an entire year, they're going to expire completely. So you can see how from the tools that we've just seen, there are a lot of ways that you can develop a very sophisticated data management policy for your organization. If you've been following along with the course, your demo bucket has versioning enabled on it. This means that the objects we place inside will retain a history of their versions as they are edited over time. Let's go ahead and click into the demo bucket, and we can pick one of the files. How about this Parks and Landmarks from Detroit? We can open up the file and make a quick change to the data. Why don't we just go ahead and delete this column here? Now that's a pretty big change, and if that were a mistake, this is something that our S3 bucket versioning could save us from because we would have the old version. Let's go ahead and save that and head back to S3. We'll go back to the demo bucket and re-upload the file. That's how you create a new version of anything. You just upload it again. So we'll click Upload, then Add Files, and add that CSV, and click Upload. Hit Close, and we can click back into the file and click this Versions tab right here. Now you can see that we have two versions maintained on the file. We have the current version and the past one, which we can click and download separately. You can see here we've got the version ID designating that we are looking at a past version and not the current one. So in this way, turning on versioning for an S3 bucket allows you to see back in time and make sure that any accidental object deletion or modification is not a catastrophe, because you can always get back to an earlier version of the file. Throughout this course, if you're following along, you're going to be building resources in AWS, and each one of these is going to have some cost associated with it. If you look at AWS's documentation, you can see that the free tier that exists can cover the cost of a lot of these resources if you are a first-time subscriber to AWS. There's a lot that you can do in the first 12 months that is free. However, you always want to keep track of the things that you build and delete them whenever you don't need them anymore to make sure you don't encounter any unexpected costs at the end of the month. So that's what we're going to do at the end of every chapter. So, in order to take care of what we've built in S3, we need to do a couple of things. First, let's work backwards by starting with a simple notification service. We're going to delete the topic that we use to email. So I'll go into Amazon SNS, which I got from my frequently accessed services, or by typing SNS up here in the menu. I'll go to Topics, highlight the checkbox next to S3 demo notifications, and click delete. I'll have to confirm by typing delete me in the text box, which is something that happens a lot throughout AWS's graphical interfaces. They'll have you type the word delete or copy and paste or type out the name of a resource in particular just to make sure that you are doing what you intend to do. So, okay, let's head back to the dashboard by clicking the logo button here. And we can go into the S3 service, either by going to recently visited or by typing. We've got 2 buckets here from the course. Now, the first thing I want to mention here is that the demo bucket is something I'm going to keep around for using later in the course, and you might want to do the same. So I'm just going to delete the secondary bucket here from the Ireland region, but if you'd like to delete both, it's going to be the exact same procedure. So just repeat that for the primary bucket if you so choose. I'll click the checkbox here. Now there are really 2 ways of doing this. I can click delete and it will prompt me to empty the bucket first, or I can empty the bucket first and then delete. Let's go ahead and just click delete and I'll show you what it says. You get a warning here that buckets have to be emptied before they can be deleted, and they give you a link to this thing they call the empty bucket configuration. So here, to empty the bucket, I have to confirm by typing permanently delete. You can type it or you can cut and paste it. Click empty, and then once this goes green, you can exit. The bucket is empty, so you can highlight it and click delete. Here I'm going to have to copy and paste the name of the bucket to confirm, and I can click delete bucket. All right, from here, like I said, I'm going to keep the primary bucket around for future purposes, but feel free to repeat that process if you want to clean everything up. All right, we'll see you in the next chapter. When you create an EC2 instance, you're asking AWS to start a virtual server for you. Although it's sometimes easy to forget, this takes place on actual hardware, somewhere deep in Amazon's data center facilities for that availability zone. Of course, a virtual machine is simply a way of giving you a virtualized slice of what's on the underlying hardware. A bit of the CPU, some of the RAM, etc. So, in the beginning, if you needed hard drive space, you'd use what's called instant storage, a slice of the hardware's disk drive. Instant storage uses the disk attached to the instance's hardware. It has the lowest possible latency, survives reboots, and is suitable for ephemeral storage. It might be disk-based or SSD-based. Now, having said that, it does not persist when the instance is stopped, although reboots are fine. It cannot be encrypted, and is not part of a snapshot taken for an AMI. It cannot be detached or backed up on its own, and it has a fixed size tied to the instance size. In short, instant storage is good for temporary uses like caching, but its overall usefulness is limited. Enter AWS's Elastic Block Store, or EBS. EBS is network attached storage, meaning that it has a lifecycle separate from the instance to which it's attached. If the instance is stopped, or even fully terminated, the EBS volume lives on. This feature alone allows us to unlock the true elasticity of AWS Elastic Compute Cloud, or EC2, instances. It means that we can shut down or sleep instances when we don't need them, such as at night or after business hours. Since on-demand EC2 instances are charged hourly, this saves us money, and because EBS stays persistent, we can pick right back up where we left off the next day. Since EBS is network storage, it can then be detached from one instance and attached, even at runtime, to another instance, and the data persists. You can also attach multiple EBS volumes to a single instance. And unlike instant storage, EBS can be grown on demand, giving you extra capacity when you need it. Just be aware that you will need to make the operating system aware of any capacity changes. EBS volumes can also be created as encrypted volumes. The encryption is seamless and visible to you as the user of the attached EC2 instance, but impenetrable to anyone who might gain access to the volume without permission. What about reliability? Hard drives have a notorious failure rate, and with a vast number of hard drives AWS has deployed at any given time, failure is a certainty. The good news is that EBS is very reliable. Within its availability zone, an EBS volume is automatically replicated. This replication gives EBS 5 nines of availability, meaning you can expect about 5 minutes of downtime in a year. But we know that availability is not the same as durability, and disks are volatile. AWS advertises that EBS has an annual failure rate of between 0.1 and 0.2%, making EBS 20 times more reliable than the typical off-the-shelf disk, which carries a failure rate of about 4%. Of course, AWS gives you the tools to make sure that even those In this video, we're going to look at how to create and configure multiple EBS volumes for an Amazon Linux EC2 instance. For that, we'll need to head into the EC2 section of AWS, which I've recently visited, so I've got the link right here. Click in, and let's go to the big orange button, Launch Instance. Click that, and we'll be at the EC2 creation wizard. First, we need to give this host a name. We'll call it EBS Demo 1. 1 because we're going to have a second one of these in a few minutes. For Amazon machine image, we'll take the default of Amazon Linux 2. And under instance type, we'll also keep the default of T2 Micro. Here under key pair, we either need to select or generate an SSH key that we use to log into the machine. So click Create New Key Pair. This SSH key will be used throughout the duration of the course, so give it a name you'll remember. I'll call mine Storage Demo Key. Keep everything else at default and click Create Key Pair. That will download to my machine, and we'll use it in a moment. Under Network Settings, you can see we're creating a new security group. It allows SSH traffic from anywhere in the world, and we're getting a warning that that is not particularly secure. I agree with that. In production, you would never want to create a rule that allowed SSH from anywhere in the public. However, for demo purposes, it'll work just fine. Alright, configure storage. Because this is a storage course, we want to click the Advanced button and see more details. There's one volume on this machine right now. Clicking the triangle will expand it. We can see that its storage type is EBS, and it has a device name, dev/xvda. You don't need to memorize that, but take a good look, because we'll be seeing this in a moment. We have a snapshot ID, as well as a size in gigabytes of 8 gigs. We have a volume type of GP2, and if you click the drop-down, you'll see several options here. GP2 and GP3 are both the general purpose SSD that is the standard for most EBS use cases. But if you want to learn more, you can click on Info and see a sidebar pop up that gives more details. And even more than that, you can click on EBS volume type here at the bottom and see a lot of information about the different cases for which each of these volume types is suited. GP2 and GP3 are pretty similar. GP3 is newer and is cheaper and allows you, if you select it, to specify your own IOPS and throughput. GP2 scales its performance with volume size. We'll keep it at GP2, the default for now, and keep going. Delete on termination is set to yes, which means this volume will go away if the instance that we're creating now is terminated. Encryption is set to no, and we'll keep it that way. Now let's create our second volume. Click the button that says Add New Volume. We'll make some different choices on this one. The device name of devsdb is filled out for us already. Snapshot, we're going to leave blank. Up here, we have a snapshot ID that refers back to the Amazon Linux image that's going to form the basis for this root volume. Down here, with no snapshot selected, it means we're going to get a blank volume with no data on it. The size in gigabytes of 8, we will change to 6, just so that later when we're looking at these at the block level, we'll see the difference very easily. The volume type can be GP3, can be GP2, it doesn't really matter, but I'll make them match. Now, for delete on termination, I'm going to select no, because that allows us to use the feature of EBS that says that even if this instance terminates, we'll still have the EBS around and can attach it to a different instance. For encrypted, go ahead and say yes, and you'll be prompted over here to select a KMS key. We've not created one separately, but that's fine, because, like with S3, server-side encryption can be done by means of a key that's maintained by the AWS service. It's called AWS/EBS, and if you click it, everything will be fine, and this volume can be encrypted. You won't need to know the key or anything about it. It'll just be a seamless encryption whenever things are read from or written to the disk. Now, that puts us at the end of the wizard, and we can choose Launch Instance. It'll take a few moments for this instance to spin up. To watch it, click the ID link here. This takes us to our list of EC2 instances, and in a moment you'll see the instance state will change to running. At that point, we can log in. Alright, this instance is created. If we click the checkbox on it, we can see some details down below. Let's copy the public IP address right here, and head on over to the terminal. Before we can use our SSH key to log into the machine, we'll need to apply some different permission bits than it downloaded with. Type chmod, then 400, and give the path to the key. For me, it's in my Downloads folder. And now that that's done, I can use it to SSH to the instance. If you want to know more about how that works, check out one of my other courses, AWS Deploying and Provisioning. Alright, we're going to type SSH, then give the public IP, -i flag, and the path to that key. That's going to take the place of a password. And before we execute this, we need to give a username right here before the IP. That user will be ec2-instance @ There we go. That'll log us in. Now, just like anytime we go to a host for the first time, SSH is asking us to accept its fingerprint. We'll say yes and hit enter. And here we are. We're logged into the machine, and we can check out the storage situation. We're going to use the disk-free command, df-h, and we'll see a few things. All right, several file systems here. The temp ones are memory-based file systems, so we don't have to worry about those. And we can see one here that is larger than all the others, 8 gigabytes in size, XVDA1. Okay, so you should recognize that is similar to XVDA, which was our root block, but it's not exactly the same. So what's going on here? Let's find out by typing lsblk to list our block storage. Okay, now we can see that XVDA1 is a partition of XVDA, that root device. So that's where our 8 gigabyte drive comes from, and you can see its mount point is /. So this is all the storage on the device, XVDA1. There's something else here that says XVDB. And what is that? That is not the name that we expected. We expected to see dev SDB. Well, there is something on this machine called dev/SDB. Let's take a look at it. And we can see that it's actually a symlink. So when we see XVDB here, that is actually our second volume, the 6 gigabyte volume. And we can recognize that here as well under the lsblock command by the 6 gigabytes. So we know that this represents our second volume. AWS documentation states that EC2 will take those device names and symlink them to other things. So you can see also with dev/xvdb that this is also a symlink, it just goes to its own name. So there's no redirection there. All right, so now that we know what's what, how do we actually take advantage of this 6 gigabyte drive? Well, we're going to need to mount it, and before we can mount it, we're going to need to format it. Let's check out if this drive is formatted or not by using sudo and then the file command, file-s. We'll point to dev/ and we'll use this name, xvdb. If we see the word data here, that means this is an unformatted drive. We need to format it using something called mkfs. We use sudo again, then mkfs-t, and the format type of ext4, and that same path, dev/xvdb. Okay, now that command has finished its work, we can run file again and see a much different output. Instead of just seeing the word data, we see details on how the file system is formatted. Okay, great. So let's do df-h again to see if anything has changed, and it really hasn't. We can see just the one root path here. Now we need to create a mount point. So a mount point needs a folder. Let's create one. We'll use sudo again and make a directory with mkdir. And we'll call it /ebs-encrypted because this is our encrypted volume. So it's just an empty folder, but we're going to use the mount command now to connect it up to that disk that we just formatted. So we'll say sudo mount /dev/xvdb/ and now the folder name. So we have sudo mount, the name of the disk, the name of the mount point. Okay, that seems to have done something. So let's go cd into EBS encrypted and look around. Okay, it does look as though there's a file system going on here. With a file system, we should be able to create a file. So let's try to vi hello.txt or something like that. We'll say hello and save the file, and can't open the file for writing. So let's exit out of here and figure out how to resolve this. So you can see that this volume, this part of the file system, is owned by root. We need to change that. We're not logged in as root, we're logged in as EC2 user. So if we want to be able to use this file system, we need some ownership over it. We use the chown command, but we've got to use sudo because that is a privileged command. chown, we'll say EC2 user, EC2 user, to make both owner and group the same thing. Dot, which is our current directory, and we'll give the -r command just for fun to be recursive, even though we don't need it right now. Now if we do ls again, you can see that the ownership has changed, and I should now be able to use vi to open up a hello.txt, put a message in there, write and quit, and save it successfully. I can open up the contents, I can do ls again, and now that you can see, we have an encrypted EBS volume mounted on this EC2 instance, usable and writable. In this video, we'll expand the size of the EBS volume we just created, and then update the operating system to make that space usable. To do this, we'll need to head back to the AWS console, specifically into EC2, and then to our list of running instances, which I can get from clicking here. Click the checkbox next to EBS Demo 1. You see the details below and can click the Storage tab to find out more about the storage volumes. You see both of our device names here. And recall that SDB is our secondary EBS at size 6. This is the one that we want to resize. To do that, click on its volume ID here, and we'll be taken to another part of the EC2 console, the volume section, as you can see highlighted here. If we check the checkbox next to this volume and go over to Actions, we can modify volume. This will allow us to change the volume type if we wish, or, in the case of this demo, to change the size from 6 to 10. Click Modify. We're being told here that this In this video, I'm going to demonstrate how we can detach an EBS volume from this instance and attach it to another. In order to show this functionality, I'm going to need a second EC2 instance. Now before we do that, please take note of the availability zone that EBS Demo 1 is in. We want to make our second instance in the exact same AZ, because volumes are unique to an availability zone. We can only detach and reattach within this AZ. For me, it's US East 1A, but it may be different for you. Click Launch Instances. Now we'll call this EBS Demo 2. We'll keep the same AMI, which is Amazon Linux 2, and the same instance type. For the key pair, instead of creating a new one, we'll use the drop-down and select the one we've already got, Storage Demo Key. Under Network Settings, instead of saying that we have no preference for the subnet, we'll click Edit, and choose the one that's in the availability zone that matches EBS Demo 1. For me, that's right here, US East 1A. We'll keep everything else at the default, allow it to create the SSH from the world security group, and keep storage at just the one root volume. Click Launch Instance. Now, while this instance is being created, we can click into the ID of the instance and head back to the EC2 console. And while this is being created, we can take a step that we need to take on the first instance before we can proceed. So head back to the console. I'm here logged into EBS Demo 1. You'll remember if you use the diskfree-h command that we've got xvdb mounted as EBS encrypted. In order to proceed, we're going to have to unmount this block device. So say sudo umount, not to be confused with unmount, that's umount, -d, and then the name of that device, /dev/xvdb. All right, now we have unmounted the device, which we can confirm, and then exit. Okay. Back on the EC2 console, EBS Demo 2 is now up and running. That's great, but before we SSH to it, we need to detach the volume from EBS Demo 1. Let's clear filters here so we can see that other instance. Here's EBS Demo 1. If we click the checkbox next to it, we can go to the Storage tab, scroll down and see that 10 gigabyte volume that we modified earlier. Click the volume ID, and once again we'll go to the volume section. We're looking at just that one volume, which we now want to detach from EBS Demo 1. Check the checkbox, go to Actions, and then choose Detach Volume. Confirm by clicking Detach. If you scroll to the side, you'll see that this stays in use for a few moments and should become available again. There we go. Now the volume is available to be reattached. Check the checkbox again, go to Actions, and then Attach Volume. Now here under Instance, we can hit the drop-down and attach to EBS Demo 2. The new device name you can edit, but we'll take the default. It's called dev/sdf. Click Attach Volume. If you look at the status now, you can see that that volume is in the attaching state. Let's head back to the console. Now, we need to connect to our EBS Demo 2. So we're actually going to need to fetch that IP address from the EC2 console. Let's head over to Instances, unclick EBS Demo 1, click on EBS Demo 2, and copy the public IP address. Now back to the console. SSH EC2 user at IP address -I, and then refer to your key. Say yes to the fingerprint. And now here we are on EBS Demo 2. The df command shows us just the mounted root drive, but if we do ls block, we'll see that we have xvdf, which is no doubt a symlink for dev/sdf, which we saw referred to in the AWS console. And there it is. So we need to do just like we did before. First, I want to check by running sudo file-s on dev/sdf. Is this volume formatted? It would rather us use not the symlink, but xvdf, so let's try that. There we go. We did not get the word data back. We got all this detail, which shows us that it is already formatted, which is exactly what we'd expect because this is the same EBS volume that we just used on the other instance. All we need to do is create a mount point. So let's do that. We'll create an empty folder. We'll use sudo, make directory, and we'll call this one /EBS reattached. That's an empty folder, which we can mount using sudo mount dev/xvdf, and then the name of the mount point. Hit enter, and we should be good. Let's cd into EBS reattached. Okay, I can see the hello.txt file that we had before, and open it up. And with that, we have detached an EBS volume from one instance and restored it by attaching it to a completely different instance, carrying on with the same data. As I mentioned, it's possible to take snapshots of your EBS volumes to ensure that you have backups of your critical data. Let's go into the EC2 section and see how this works. Alright, here we are looking at EBS Demo 2. It's already highlighted. If you go down below and click the Storage tab, we can see details of the two volumes attached to it. We have the 10 GB secondary volume and the 8 GB root volume. Let's click the ID of the first one, the root volume. We're taken to the volume section over here on the side, and we can select and highlight that volume. Then go to Actions and choose Create Snapshot. This is how we create a one-off manual snapshot of an EBS. We'll call it EBS Demo 2 Root Volume Snapshot, something like that, and click Create Snapshot. From here, we're taken back to volumes, but you can see the snapshot ID up in the header, and click it. And we can see that it's already making progress on taking this snapshot. If you want to refresh the page, you've got the button right here. Okay. Now the snapshot is complete, and it's in the available state. So what can we do with this? If I go to Actions and click the drop-down, I can see that I can create a brand new EBS volume from the snapshot, or I can create a machine image. Remember when we created the EC2 instances to begin with? We chose the Amazon Machine Image, or AMI, for Amazon Linux. This is how you create your own AMIs. If I had modified this root volume in some way, say by specially installing certain packages or configuring it in a way that's important to my business, I can create a new AMI from this snapshot to use as the basis for future builds of EC2 instances. Let's see how that works. Click Create Image from Snapshot. On this screen, we need to give it a name, and we'll just call it EBS Demo AMI. We'll keep everything else at the default and click Create Image. In order to address the limitations of EBS and provide users with truly flexible storage, AWS introduced Elastic File System. EBS's first claim to fame is that it grows and shrinks in size, not manually on demand like EBS, but automatically in response to your usage. You don't even have to update the operating system because EFS always presents what looks like many petabytes of storage. EFS is not block storage like EBS. Rather, it's a file system that can be mounted by NFS 4.0 or 4.1 clients. Unfortunately, that does mean that Windows cannot natively mount EFS. However, you can enable an NFS service on certain versions of Windows that provides an NFS client, or use a third-party client. Alternatively, you can stand up a native CIFS file system and use another AWS service, FSX for Windows, which we'll explore later. As a network file system, EFS can be mounted by many clients at once, making it well-suited for tasks that require shared disk space, such as horizontally scalable web apps or parallelizable data processing jobs. This makes EFS a potential NAS replacement. And unlike EBS, elastic file systems can be mounted from outside AWS. If you're using AWS Direct Connect, you can have an on-premises instance, or anything that can use NFS, mount EFS. This makes EFS a perfectly viable way to get data out of your data center and into the AWS cloud. Before an instance can connect to an EFS file system, it must have at least one mount target. A mount target is an AWS resource that provides the NFS connection between the client and the scalable storage in EFS. It's like the front door of EFS. You'll make one when you create an EFS instance for the first time. The mount target has a DNS-A record that resolves to the IP of the backend file system. This is the domain name that you'll use on the client, say an EC2 instance, when you connect to EFS. As is the case with other AWS resources, such as application load balancers, AWS discourages users from connecting using the IP address directly, as it may change without warning. On the other hand, the domain name of the mount target stays consistent and reliable. You may have at most one mount target within an availability zone. If you have multiple subnets, as is the case in this diagram, you'll choose one to house the mount target, and any instance within any subnet of the AZ will be able to resolve it and use it. Now we have established two connections to the same EFS. These two instances are sharing the backend storage. What the first instance writes, the second one can read, and vice versa. One of the most useful features of the mount target is that security groups can be attached directly to it. AWS security groups are like portable firewalls that can be attached to different types of AWS resources. With security groups on your mount points, you have maximum control over what instances in your account can mount this file system. Finally, if you want instances in another availability zone to connect to EFS, you'll need another mount target in that AZ. Here, with two mount targets, we have 4 instances sharing the EFS volume. Imagine these are all workers in a distributed data processing job, or that they're all members of an auto-scaling group that serves a web application. These hosts can all share data seamlessly with fairly low latency. Speaking of which, users have some control over the performance of EFS. To configure IOPS, you can initialize a file system in one of two modes, general purpose or max IOPS. AFS documentation states that file systems in the max IO mode can scale to higher levels of aggregate throughput and operations per second, with a trade-off of a slightly higher latency for file operations. As for throughput, by default, EFS throughput scales with the amount of data stored on the file system and employs a bursting model. In general, AWS increases your EFS IOPS capacity along with the size of your instance. This can lead to some undesirable situations. If your volume is quite high but your overall dataset size is low, you may find that you're throttled at times using EFS. If you know that you're going to need higher sustained throughput than what bursting provides, you can also use provisioned throughput to pay for a certain baseline of throughput performance. It's all a trade-off between cost and functionality. To get the full picture of your options, be sure to consult Amazon's document page, Amazon EFS Performance. Even with those special configurations, AWS has made significant improvements to EFS since its launch. First, they've seamlessly deployed numerous performance enhancements, including one that tripled throughput for reads and another that increased IOPS by nearly 5x. Not only that, they've introduced S3-style storage classes to give you even more control over the cost and behavior of your file system. As shown here, there are multiple options for how to deploy. For instance, EFS 1 Zone trades a bit of durability for significant performance and cost benefit. Even in this mode, EFS data is still replicated in the background to give you better durability than running your own network storage. It's just limited to one availability zone. There are also infrequent access tiers and intelligent tiering, just like with S3. Meanwhile, EFS takes backups that can be replicated out to other AZs, giving you plenty of options to tune your desired price and performance. Now, let's get into the console and see how this works. In this video, we'll keep using the two EC2 instances from the previous EBS lessons to mount an elastic file system. We'll start by creating a security group that will allow both of these instances to talk to EFS. There are multiple ways to approach using security groups for purposes like this, and you can learn more about them in my other course, AWS Deployment, Provisioning, and Automation. For this demo, we'll go with something simple and create a group that allows NFS file system traffic from any host in the entire VPC in which these instances reside. So for that, we'll need to go find the VPC and its IP range. Let's head into the EC2 section of the console. Click on Instances Running to see a list, and there are 2 demo instances. Click the checkbox next to one to see its details, and go to the Networking section. Here you see the ID of the VPC where this server lives. Click it, and we'll go to the VPC section of AWS. Okay, here we see our VPC, and right here on the line, it's CIDR block. A CIDR block represents a range of IPs, and this one, 172.31.00/16, represents all the IP addresses within this VPC. Both of the EC2 instances we've created then are within this range, so if we create a security group that allows NFS traffic from this range, they'll both work. So I'm going to go ahead and copy this, close the tab that opened, and that'll put us back in the EC2 section. Over here on the side, I'm going to scroll down to Security Groups. Here we'll click Create Security Group. We're going to call this something descriptive, which would be NFS from default VPC. And we need to give it a description. So we'll say allow NFS traffic from anywhere within the VPC. Security groups actually belong to a VPC, so that's what this line here indicates. As for inbound rules, let's click Add Rule, and we'll add our NFS rule. In the drop down, you can put in any port that you like, but there are some presets here, including NFS. Go ahead and click that, and it will get preset with the port 2049. As to the source, we can say custom, anywhere, or my IP. We'll go with custom, and here we can paste in that CIDR block we just copied. We can leave the description blank since it's pretty self-evident, and there's the description up here. And we can scroll on down. Outbound rules can stay at their default, and we'll click Create Security Group. Now, if we apply this security group to our EFS mount points, any instance that's in the VPC should be able to talk to it on port 2049. All right, with that, let's go type EFS in the search bar and head to the Elastic File System part of the console. Click Create File System. There's an extremely simple interface that you can click through to create an EFS for the first time. However, we'll get into the details. We'll call this one EFS Demo. It's in our default VPC, and standard storage class works, but let's hit Customize. Okay, let's see what kind of options we have. Storage class is either standard or one zone, which would of course put us in just one AZ. Automatic backups are enabled. This uses the AWS backup service, which we'll talk about later in the course. There's lifecycle management set up by default. As you recall, there are storage tiers in EFS similar to S3, and this rule says that after 30 days, an individual file will move out to infrequent access. That means that you may encounter some additional first byte latency hitting that file, but you'll have a much better balance of price and performance for this file system. And you can change this however you like, but we'll keep it at default. Performance mode is general purpose or max IO, which will have you pay a little more for increased throughput. Throughput mode can also be bursting based on demand or set up in advance by the use of provisioned throughput. Encryption will keep at its default. No tags needed for this, and we'll click Next. Now, this is interesting. Mount targets are the endpoints that our EC2 instances will actually talk to when they want to mount this EFS. So you can see that we've got one in basically every AZ that's part of this VPC. That's nice, and that's what we want, but we do want to change their security groups. They've all got this default security group, and if you go look that up, you'll find that it is the default VPC security group, which is actually pretty wide open. What it does is it allows all traffic within the VPC from any resource that also bears this security group. That is an interesting pattern. I like the pattern of creating security groups that trust themselves. That way you can sort of badge different resources with the security group that will allow it to get to things. That's very nice. But in this case, because it allows all ports, it's a little more expansive than I would like. I'm going to go ahead and just X these all out. And instead, we'll use the dropdown to choose the NFS from default VPC security group. You can see that appears in the background, so you kind of have to click off of it to see the effect sometimes. Choose that for all of these mount targets. And now we'll click Next. On this screen, you can actually set up some file system policies that will apply to the entire EFS. If you click through these checkboxes, you can see a little bit of how these work. You can prevent root access with this one. You can enforce read-only access with this one. These are all editable, so you can go in there and make tweaks, or you can write your own. That's a little bit outside of the scope of what we want to do in this demo, though, so I'm going to uncheck this and just click Next. But be aware that you can always, in AWS, click the Learn More buttons that appear frequently to find out details. Click Next. The next screen is a summary. If everything looks good to you, go ahead and click Create. Our EFS file system is now in creating mode. In a few moments, it will become available, as it has already, very fast. In the next video, we'll see how we can connect to it from our EC2 instances. Now that we've got our EFS demo created, let's see what it can do by mounting to it from two different EC2 instances. In order to demonstrate this, I've kept around the two machines from the EBS part of this chapter, EBS Demo 1, here with the white background, and EBS Demo 2. You can see that I'm logged into two distinct machines by the differing IP addresses in the prompt. Now if we head back to the AWS console and click into EFS Demo, you can see details of the file system and the orange Attach button. Let's click that. Our default is Mount via DNS, which is what we want to do, but we have two choices underneath. We can use the EFS Mount helper, or we can use the NFS client. The first command is much shorter and easier to work with, so I will want to copy that and use it over here in the terminal. However, before I'm able to use it, there are a few steps. First, we have to make sure that the helper package Amazon EFS Utils is installed. Type sudo yum install -y to answer yes automatically to all prompts, Amazon EFS Utils. This will install the special software built and maintained by Amazon that makes mounting EFS easier. And we'll need a mount point, so let's create one using sudo make directory /EFS. Now with those two steps done, we should be able to paste our command, and with a slight modification, make it work. We want a slash here so that it's an absolute path instead of a relative path. At this point, we should have our mount complete. If you do disk free with df-h, you can see that we do have /EFS mounted. And it's mounted to something that's on the network. If you look at the size available, that's 8 exabytes. And in fact, if you say df with no extra arguments on it, you'll see that expanded. Lots of bytes available. Of course, this is because EFS will expand as you need it. It basically has infinite space. As always, it's important to clean up the resources that we created so we don't incur any unexpected charges from AWS. Let's start with EFS. I'll click into it under my recently visited services. Here's our EFS demo. I'll click the check mark next to it and go up to Delete. As you often have to do in AWS, you need to provide some sort of confirmation by typing or copying in a phrase or ID. So we'll put in that ID and then hit Confirm. This will delete the EFS and the mount targets. Now we want to head to the EC2 section and get rid of our instances. I'll type EC2 in the search bar and go here. Click Instances Running, and you have some options here. Later on in this course, I'm going to continue to use EBS Demo 1 to show things like the file gateway, so you might want to keep it around. I'll keep it around, but if you want to, you can delete both of these instances at once, or just click EBS Demo 2, go up to Instance State, and choose Terminate Instance. We're given a note down here about deleting EBS volumes. Any ones which do not have delete on termination set to true will persist, and we have at least one volume like that, so we'll need to go to the volume section next. For now, click Terminate. This will start our EBS demo machine terminating, and when it's done, we can head to the volume section and take care of those EBS instances. Okay, you can see it has disappeared from our list because our instance state filter is on running. If you uncheck that, you can see that it's in the process of shutting down. After a few moments, the instance has transitioned to the terminated state, and we can head over here on the left to volumes. Because I've kept around EBS Demo 1, I still have this 8 GB volume that's in the in-use state. If you chose to delete both instances, that one would have gone away. We had a third one, which was the root volume of EBS Demo 2, which has disappeared. What we have left is this 10 GB volume, which is in the available state. That's the EBS volume for which we chose do not delete on termination of the instance. So it's sitting out here, able to be attached to another instance if we like, and we want to go ahead and just delete it. So click the checkbox next to that 10 GB volume, go up to Actions, and choose Delete Volume. Okay, with that gone, there are a few other things we still need to clean up. Remember, we created an AMI and a snapshot from one of these volumes. We'll start with AMIs. Check the checkbox next to this one, go to Actions, and then the word here is Deregister AMI. Go ahead and confirm, and we'll head to snapshots. Be aware that you need to delete AMIs before snapshots because there's a dependency there. AMIs depend on the snapshot existing, so you can't delete the snapshot first. Here under snapshots is the snap that we used to create that AMI, and we can go ahead and go up to Actions and choose Delete Snapshot. Okay, with that we've cleaned up everything that we created in the part of the course related to EBS and EFS. Amazon FSx is a multifaceted service wherein AWS offers managed versions of several popular file systems: NetApp ONTAP, OpenZFS, Lustre, and Windows File Server. Throughout AWS, managed refers to systems that you could set up for yourself, but for which AWS abstracts away the complexity of configuring and administrating them on your own. This makes it easy to stand up sophisticated infrastructure without needing a certification in, for instance, Windows file systems. In fact, FSx is probably the best AWS option for those interested in network-attached storage for Windows workloads. Since this course otherwise focuses quite a bit on non-Windows storage, I thought we'd take this example and see just what FSx can offer with a few simple clicks. First of all, FSx for Windows behaves just like any Windows file server file system, provisioning a CIFS file system and allowing applications and end users to connect via the SMB protocol. File and folder permissions are handled by your own on-premises Active Directory or by AWS Microsoft Managed AD, which is another managed service offered by Amazon. FSx for Windows file system is highly available, which is often something that's challenging to implement from scratch. Behind the scenes, Amazon distributes this file system over multiple availability zones, offering high uptime and automatic failover. In addition, FSx can set up a Windows Server failover cluster, just the same multi-node HA setup you'd implement if you were doing this on your own. FSx is cost-efficient due to data deduplication and compression options. Amazon claims turning on this feature for the Windows flavor can cut an FSx bill up to 60% for general-purpose workloads. Like all AWS managed services, patching is handled for you and can be scheduled to happen at a convenient time. FSx also does automated daily AWS's Relational Database Service, or RDS, can take a lot of work off your hands when it comes to relational databases. Without RDS, deploying a database to AWS can be a rather involved process. You'll provision an EC2 instance, attach storage, say using one of the services we've discussed like EBS, EFS, or FSx, and then you'll have to install and configure the database instance yourself. Patching becomes an ongoing concern both for the database and the OS it's installed on. And if you want a read replica or a standby for failover, well, your database platform may provide tools, but you're on your own to implement them. Good news, RDS manages all of this for you. With RDS, you can select one of 6 different relational database platforms: Oracle, MySQL, PostgreSQL, SQL Server, MariaDB, and Amazon Aurora. Let's take a brief aside to talk about Aurora. Amazon Aurora is AWS's proprietary database engine. It's compatible with MySQL and Postgres, and meant to outperform traditional expensive database engines. AWS advertises that Aurora provides 5 times the throughput of MySQL, and they're positioning Aurora to compete with the likes of Oracle and SQL Server. Aurora is also highly available and durable, automatically replicating itself across 3 availability zones. It's even available in a serverless flavor that auto-scales in response to use, rather than needing to be pre-provisioned. Aurora's compatibility with existing engines means that it's an attractive migration target for organizations moving relational databases to the cloud. Back to RDS in general. When you run a database on RDS, AWS handles the compute for you. You never need to remote into an instance to manage your database processes. Of course, that doesn't mean that RDS doesn't have compute resources. Your database needs CPU and RAM to run on. With RDS, the details of the underlying compute resources are abstracted away. Under the covers, is this Postgres instance running on Ubuntu, Red Hat, or, most likely, Amazon Linux? Who cares? As long as it responds on port 5432 when we want to connect, we don't need to know. But we do need some control over the provisioning of the compute resource. So in a similar way to EC2, RDS provides us with DB instance classes. The instance classes of RDS mirror the naming conventions of those for EC2. Sample types include standard, memory optimized, and burst-capable database instance types. Platform support varies. Some database types only support some instance classes. We can convert a database instance to another instance class whenever we like, but be aware that this will incur a reboot of the database. It's possible to reduce the outage time in a situation like this, or perhaps more critically, in the case of an unplanned outage. When you select multi-AZ deployment, RDS will automatically, synchronously, replicate data to a standby instance of your database in a neighboring availability zone. Users continue to read from and write to only the primary instance, but if that one goes down, AWS will update the DNS record associated with your RDS instance, and it will resolve to the quite fresh, hot standby. Some applications will still need to reconnect, but the result will be much less problematic than a full-blown outage. AWS claims that this failover usually occurs in under 2 minutes. AWS uses a variety of methods to achieve this replication. It varies based on the DB platform and its available tools. Just keep in mind that no matter the platform, synchronous replication means that every time you write, you must wait for that write to replicate to the standby. If your use case can sustain the additional write latency, multi-AZ is a very attractive failover option. You can fully stop database instances, giving you the same flexibility to control uptime and cost that we enjoy with EC2. Just be aware that you can only do this for 7 days at a stretch before AWS will restart the instance automatically to ensure that it does not fall behind on required maintenance and patching. Another nice feature of RDS is the ability to create read replicas. Read replicas are copies of your source database that are kept up to date as changes are made in the source. RDS read replicas are kept in sync using the existing asynchronous data transfer options available in MySQL, MariaDB, and Postgres, meaning those are the only DB platforms currently supported. That transfer is encrypted even when the replica is in another region. And since I mentioned it, yes, your replica can be in another region, giving you great high availability on the chance that an entire region goes down. So why create a read replica? Well, one big reason is to reduce load on transactional systems. You can point reporting tasks or other query-only workloads to the replica, ensuring your primary system remains responsive. You can create unique instances on the replica, if you're using MySQL, to enhance its performance without impacting the primary. Read replicas can be promoted to master manually in a scenario where the primary fails. They can be cross-region, giving you additional disaster recovery assurances. And finally, your read replica can use a different instance type than your primary, giving you more control over your cost-performance ratio. One last note about replicas. MySQL can actually be replicated to Aurora since they're compatible, so even if you don't start with Aurora, you have an easy way to take advantage of its many performance and storage benefits. Back to management. Don't forget about patching. Both the underlying OS and the database engine need regular updates, some of which may be critical for security. RDS manages that too. We can choose a maintenance window, say 1 hour every Sunday at midnight, and RDS can automatically apply any OS patches and minor database level updates that are available for our chosen platform. No downtime unless the update does require a reboot. OS patches can be scheduled, taken immediately, or deferred. However, AWS will mark some OS updates as required and will not let them be deferred indefinitely. As for patching the database engine, well, if this capability gives you pause, fear not. AWS has considered that not all database updates are backward compatible or safe for your data. So, auto-patching is entirely opt-in, does not extend to major releases, and varies based on the platform. Major updates to the DB engine, you will need to initiate yourself. You'll want to create snapshots of your data and handle any data conversion that needs to take place. Still, auto-patching for minor updates can be a great time saver. It should come as no surprise that RDS gives you options as to the underlying storage of your database. Much like instance class, the storage option can be changed with minimal downtime. Magnetic is the cheapest and slowest option, only available for backward compatibility purposes. General purpose scales performance with storage size. Provisioned IOPS lets you pay more to specify the performance and size you want. Finally, let's create a MySQL database using RDS. But before we do that, I want to visit the EC2 section of the console so we can create a security group that will allow us to connect to the database on the appropriate ports. Let's head into EC2. We're going to go down the side here and choose Security Groups. Here, click Create Security Group. We'll call this rule MySQL Access from World. And go down to Inbound Rules and click Add Rule. As with most common ports, there is an entry in the drop-down for MySQL. We start typing, we'll see it. MySQL/Aurora on port 3306. The source can be custom, anywhere, or myIP. What we want to do is allow anywhere on IPv4. Now, of course, you wouldn't want to do this in production. In most cases, what I would prefer is to have a database be in a private subnet, accessible by other resources within AWS, but for purposes of this demo, we'll make it open to the world and something that we can access from a laptop. Click Create Security Group. Oh, we do have to give it a description, so we'll say, allow MySQL traffic from anywhere. Now scroll down and click Create Security Group. Okay, so that's ready for us to use in a moment. Now we'll head to the RDS section of AWS. Come to the search bar and type RDS. You'll see this, the Relational Database Service, and go ahead and click it. Now we can click Create Database. Alright, on this screen we have a few options. We're going to go with the standard create rather than the easy so we can see some of the details of what we're choosing. We'll click MySQL, and you can see that we're set with MySQL Community Edition. And we have a number of version options down below. In this case, I'm going to select version 8.0.23, which is a few minor points behind, because I've found in setting up this demo that this is the latest one that is compatible with Aurora. Later on, we're going to create an Aurora read replica from this database, and so we need to select that version. It's possible this may change by the time you're viewing this video. You can always take a look at the AWS documents to be sure. There's also this link here that always shows up, which is the known issues or limitations. If you click that, you can see some of the specific details of things that do and don't work on this version of a database running on RDS. It's definitely worth looking at because each database engine has some unique and particular behavior that differs when you're running it on RDS. So some of this is kind of esoteric, but it may have a real impact on your workload, so be sure to check it out. All right, so we're scrolling down. For templates, we've got production, dev, task, or free tier. You can always customize this to your liking, but if you choose free tier, it's going to make some selections down here for you. You can see we've got options to do multi-AZ deployment or a single DB instance. Of course, a single DB would have no redundancy, no cross-AZ capabilities, but for purposes of this demo, that'll be all that we need. So we're going to click free tier, and you'll see that down below, chosen for you is single DB instance. So we'll scroll on down. For the database identifier, which will become part of the endpoint URL, we'll call this MySQL RDS demo. Now we need to create a login, and I'll call this MySQL _RDS _user. You can have it auto-generate a password, or you can type one in that you have to confirm here. Whatever you do, just make sure that you have the password and can use it in future steps of this video. So I'm going to type one in here and keep going. The instance class can stay at db.t3.micro, that's fine. Small instance size is all we need for this. Storage can also stay at default. As for connectivity, scroll this into view a little bit and make sure that public access is set to yes. Again, that's not really how we would set up a production database, but that's our purpose for this demo, to be able to access it from your own laptop. And to facilitate that, here we select a VPC security group in this dropdown. and look for MySQL access from world. As with many of these security dropdowns in AWS, it actually did work behind the dropdown, so just click off that and you can see that it has been selected and you can X out the default security group. All right, keep scrolling down. Password authentication option is fine. We don't need to worry about enhanced monitoring, but we do want to expand the additional configuration just for this first box here where I want to put in a name for the database. We'll call it very simply my database. That's not to be confused with the DB identifier that we gave up above. This is actually the name of the database that will get created inside the MySQL we're about to build. Parameter groups are interesting, and we'll look more at those later. There are all kinds of key value pairs that go into a database engine that tell it how to work, change little settings and things. Those are termed parameter groups in RDS, and you can take default ones, you can copy them, you can make changes yourself, so you can have custom parameter groups. Later on, we'll see what it takes to change one of those, but for now, we'll leave everything else at the default, scroll all the way down, and click Create Database. All right, now that this database is being created, let's look at how we can connect to it using MySQL Workbench. While the RDS instance is being created, we can take a moment to go download MySQL Workbench, the client that we'll use to connect to it. I've searched for that phrase, MySQL Workbench, and this was the first hit here at mysql.com, and we can click Download Now. On the next page, you'll be asked to select your operating system, and you've got a download button. From here, you need to log in or create and then log in with an Oracle web account. Since Oracle purchased MySQL, this is now a step necessary to download the software. I've already done this, so I'll leave that for you to pause and continue. But you can see that I've got MySQL Workbench installed here. And this is the first screen you see when you open it. All you need to do is click MySQL Connections and the little plus next to that, and we'll have an interface that allows us to enter in the details of this connection. Let's head back to the browser. I'll close this tab, and I'm back here at AWS. Our RDS instance is in the available state, so let's click the name of it to see details of what got created. All right, right here under Connectivity and Security, the default tab, we have the endpoint, which we can copy. That URL is going to go into MySQL Workbench here under host name, so we can delete that IP address and paste in that URL. Port will stay 336. Username will be what we created earlier, MySQL_RDS_user. To put in your password, at least for the Mac, I'll click Store in Keychain, and then type in the password that I created earlier. Click OK. Default schema should be my_database, and then we'll need to give the connection a name. We'll call this MySQL RDS Demo. Before clicking OK, click Test Connection to make sure that you don't have any typos or anything like that. And now we see that we do have a successful connection made with MySQL. So this tells us that not only was all of our data entry here correct, but also that our security group and our network settings on the RDS instance in AWS are all correct. We have a clear network path from our home machine to the RDS database. So click OK. And now we have a box here representing the connection. We can click on that, and it will establish a connection to the database. Up here, if you click the Schemas tab, you'll see that we are in the My database. No tables yet, which is to be expected. It's a brand new empty database. So we need to give it some data. To do that, click the little folder here and navigate to Chapter 4 in the exercise files. We're going to open this file called employeedata.sql. So double click on that. Let's take a look at what we've got here. At the top of the file, you'll see drop table statements. If you run these, it'll allow you to clean up everything that's in the script and run everything from scratch. Then we've got create table statements for departments, employees, projects, and project team members. So we're setting up a basic workplace schema here. Further down, we've got insert statements that put values into those tables, and on line 76, a commit. After that, we've got a couple of SQL queries that will let us confirm the data that we've put into the tables. So let's scroll all the way up to the first create table statement and highlight all the way down through the commit. Click the lightning bolt here, and everything will get created, as you can see down here below. And then we can highlight this query here to confirm that we've entered data. All right, there you can see the members of our sales team. And with that, we have now created an RDS database, logged into it with MySQL Workbench, and created some sample data. In the next video, we'll look at how to create a read replica using Aurora. I'm here at the RDS console, looking at the details of the MySQL RDS demo database we just created. What I'd like to do in this video is create a read replica of this MySQL instance using the Amazon Aurora database type. Go up to Actions, and you'll see Create Read Replica, and below that, Create Aurora Read Replica. Go ahead and click it. As this screen loads, we'll start to see some options come up, and we'll choose the latest Aurora version that's compatible with the version of MySQL that we selected. So if you click the drop-down, you'll see references to various MySQL versions, including the one we chose earlier, 8.0.23. So we can select the highest compatible version, which is this, 3.02.1, and then look at DB instance class. You'll find with Aurora that we don't actually have the option to choose some of the smallest classes that we've used before. You won't see smalls or micros on here, but you can choose this db.t4g.medium as one of the smaller, cheaper versions. If you're following along with this demo, this instance will not live for very long, so don't worry too much about charges. Alright, so moving on, we do not need multi-AZ deployment. For our database instance identifier, we'll call it MySQL, maybe Aurora, read replica. We'll go down to the next section, network security, and make sure that publicly accessible is selected. And as for availability zone, it doesn't really matter. You can leave that at the default. We do need to choose an existing VPC security group so that we can access this instance from outside. So click that and choose the MySQL access from world. Remember that Aurora and MySQL both use the same port 3306, so that security group will work for both. You can also X out the default VPC security group and then move on from there. Look over the remaining options. You see the port, as we just mentioned. You see the parameter groups are at their defaults. Everything else can stay where it is. Scroll all the way down and choose Create Read Replica. Now, this step can take a while to complete. Not only are we standing up a new RDS instance with the Aurora database, but AWS also has to set up the replication between the two databases. So we'll wait for this to be done, and then we'll see how the replication works. To monitor what's going on, click Databases, and we'll see that we've got an Aurora cluster in the creating state. So what about this cluster? Well, what you'll see in a moment is that we actually end up with 2 Aurora instances. In past versions of this course, creating an Aurora read replica resulted in just 1 additional instance. Now, the minimum standard deployment of Aurora creates a cluster of 2 instances, a read-write main instance, and its own read replica used for failover. So you might wonder, why don't we just start with an Aurora cluster instead of creating a MySQL RDS, where we then have to create a read replica and somehow implement failover for that? And I would say that's the point. That is what Amazon is trying to do. With Aurora, they're providing a very attractive value proposition to people who want that kind of managed resilience in a MySQL or Postgres compatible database. So that would work to just start with Aurora and use that for any MySQL purposes that you have in the future. If you click the refresh button here, you can kind of watch things creating, and we'll come back in a minute to see both of these databases available. Okay, now the read replica is available, and we'll want to see how the replication is working between our original MySQL and this Aurora instance. But before we connect the 2 instances, I want to point out what's going on here. For Aurora, we see 2 records here on screen, one designated replica cluster and the other called writer instance. To illustrate why, let's take a quick look at AWS docs about Aurora. You see here a depiction of a typical Aurora cluster. And the first thing to understand is that every Aurora database you provision, no matter what size, is called a cluster. Part of the reason why, as this image shows, is that Aurora separates compute from storage. There's always a common storage layer, shown here in gray, that's spread across multiple availability zones. That exists no matter what, and there's always at least one instance, which is the compute you connect to. While we chose single AZ deployment, the most common Aurora installation involves multiple instances spread across multiple AZs. In that case, you'd have one endpoint like this that is the read-write endpoint, and any additional endpoint would be an Aurora read replica. In our case, our cluster is a single AZ, meaning we just have the one read-write endpoint. Our cluster is basically this section on the left here, and the gray bar showing the storage spread across multiple AZs. Nevertheless, AWS refers to the cluster and even shows URLs for both writer and reader instances separately. The trick is that in our case, these instances are one and the same. Our writer instance and our reader instance are both wrapped up in that one instance that we have provisioned. If you take a look over here, you can see that. We've got a link for the replica cluster and for the writer instance, but if we click in to the cluster, we can get a little bit of an idea of what's going on here. It shows 2 endpoints, but you can see here the size of this cluster is listed as 1 instance. This is where things are a little bit confusing if you've chosen not to do multi-AZ. They refer to a writer instance and a reader instance as if they're separate things. But in fact, if you look at the domain names that are provided and resolve them with something like NSLOOKUP, you'll find they go to the exact same IP address. So, just as we're told here, the size of this cluster is just 1 instance. So now that we've cleared that up, let's connect to this Aurora instance and compare it with our MySQL to see how the replication's working. Let's go back in and actually grab one of those domain names using the copy button here. And then we'll head back to MySQL Workbench. I'm here on the home screen, and I'll click the plus button to add a new connection. We'll call it Aurora Replica, and we'll paste over the IP address that's by hostname with that domain name. The username will be just the same as our original MySQL instance, because of course this is meant to be a perfect replica. MySQL _RDS user. For the password, that will again be the same. Click OK. And under default schema, we'll say my database. Click test connection to make sure you've typed everything correctly. And if that works, click OK and then OK again. Double click Aurora Replica to open it up. All right, so now we've got two tabs here in MySQL Workbench, the Aurora Replica here and the original MySQL RDS database here. We'll click into that first tab and then highlight the sales query to see our initial state. I'll hit the lightning bolt on that and we can see the 3 rows. Let's imagine that I've just made a terrible mistake and deleted some important data out of the source MySQL database. We have the read replica, but that stays in sync with the source, so it's really not that much help if I've deleted something important. What am I going to do? Well, remember that when we set up an RDS database, it defaults to keep 7 days worth of snapshots taken nightly. So that means I can at least get back to last night. But often that's not good enough. We need something a little more recent. Fortunately, RDS has our back here. If we have the MySQL RDS demo highlighted and go to Actions, you'll see Restore to Point in Time. This is a really helpful feature that has genuinely saved me in real life a few times. In a moment, you'll see that we have some options that start with Restore Time. The first option is Latest Restorable Time, which is just a few moments ago. And we can also click here, and we appear to be able to put in just about any time that we want. How does RDS let us do this? Well, we have the nightly backups, but to get something in between, RDS looks at the actual change logs of the database engine. These are the logs that MySQL keeps as you update data all through the day. So it goes up to the most recent backup that we have, say last night, and replays the changes from that log through the day up to the point in time that you're specifying. So it can get really specific on a restore time. If we leave this at latest restorable time and scroll down, you see the rest of what we have to fill in here is just to say what's our new instance going to be. Because remember, RDS doesn't do restorations in place. It creates a new instance for you to log into. So you can see here, we need to give a database identifier. This is called MySQL RDS demo right now, so we can just paste that and append something like restored, so we know what's what. And then we can pretty much leave everything else as is. I mean, we can change instance type, we can change other configuration options on this database, but we really just want a replica that goes back to that point in time. So we can go all the way to the bottom and choose Restore to Point in Time. Now RDS is creating a new instance based on my previous one at that exact point that I specified. When I need to get the data back, all that I'm going to need to do is create a new connection using MySQL Workbench to go to this new database and extract the important data that I accidentally deleted. I can either from there manually restore it to the original database, or if I like, I can take all my applications that are connected to the source and reroute them to this new restored database. As usual, it's important to make sure that we clean up the resources we no longer need so that we won't be charged for them. All right, first thing I'm going to do is go to the MySQL RDS Restored, go up to Actions, and choose Delete. We do not want to retain automated backups, so we'll uncheck this, and we'll check the next thing, which is an acknowledgement that this is going to delete everything and no backups will be available. Type delete me to confirm that and click delete. As for MySQL RDS Demo, you can do the exact same steps to that database, or if you want to continue to follow along with this course, keep it around. We'll use it later in the course. For the Aurora cluster, what we need to do is click on the row for the replica cluster, and before we can delete it, we need to go to Actions and choose Promote. This will turn it into its own full-fledged standalone database instead of being a read replica of the MySQL demo. Click Promote Read Replica. This will take a moment to complete, and when it does, you'll see that this no longer says Replica Cluster. Now it's done and it says Regional Cluster, which means that we can delete this. Instead of clicking on the cluster, we'll click on the actual instance, the second row, go to Actions, and then Delete. Uncheck Create Final Snapshot, acknowledge that we don't care, and type delete me. Then click delete. And now the cluster will be on its way to deleting. Before we finish, the last thing you want to check is go over here and expand and choose snapshots. I didn't keep these instances running long enough for a snapshot to have taken place overnight. However, if you've been following along over the course of a couple of days, you may have. So come in here and check any snapshots that exist, go up to Actions and delete those as well. DynamoDB is AWS's highly available, scalable NoSQL database. You might compare it to other NoSQL databases like MongoDB. The main advantage of Dynamo is that, like RDS for relational databases, Dynamo is a fully managed service. It scales performance on demand, meaning that you can provision, and pay for, just the level of read and write performance you desire. It's also a distributed storage system, meaning its durability and availability is very high. Like S3, it can publish event streams for all its activity, and finally it's stored on SSD, which gives it very low latency. The primary artifact of DynamoDB is the table. You can almost think of this as equivalent to a bucket in S3. It's not like a table in a relational database. It's a place to store objects. You can have as many of these tables as you want. And within a table, you'll create records, which AWS calls items. Items cannot exceed 400K in size. Items can be one of a few data types. Scalars are single value types, such as strings or booleans. There are multi-values, they're like arrays or sets. And documents are complex types that combine the above two and can involve nested data structures. Using these types, what you end up with is something that is basically JSON. In this example, first and last are scalar types of string. Pilot of is a string set, more commonly called an array of strings. Finally, the whole thing is a map object, a conglomeration of the other data types into a structure that contains many key value pairs, as well as substructures like the nested object father. This kind of data model means that Dynamo is an ideal choice for non-relational data. If you need to frequently join records, you may want to look at putting a relational database on RDS or on EC2, but if your data load is high volume, non-relational, and at 400K, Dynamo is going to work really well. Now, let's discuss primary keys. Although NoSQL databases are schemaless, each Dynamo table you create should contain the same kind of data. The exact fields of the items might vary. Some fields might be optional, for instance, or just not present on some records, but there needs to be some consistency as to what's inside. So given that when you create a DynamoDB table, the first thing you'll need to do, other than give it a name, is select a primary key. Think about the format of the data that you want to put in. In the previous example, we had first, last, and pilot of, all examples of keys. For the primary key, we want to select one that will uniquely identify a record, meaning it should be present for all items. They should be diverse and evenly distributed enough within the data to be good for physically partitioning the data. And they should serve as effective keys for actually querying the data, which we'll get into. In some cases, you might have an actual ID or a GUID, like an employee ID, to serve as a primary key. When it comes to querying, you have just a few simple choices. You can query on that kind of primary key, or you can query on what's called a sort key, which is a kind of secondary key. You can create custom indices on which to query. These can be comprised of any other field on an object, but they must be maintained and they take up space. They also often force you into a two-part query model where first you query the index, obtain a primary key, and then use that to query the object you really want. Finally, you can perform a full table scan, retrieving all records, and filter the result, which can be a slow process. You really want to choose your keys and your indices well so that you can minimize the result set that you've got to filter at the end. So, what's a sort key? Sort keys combine with primary keys to act like a composite key. will extend your namespace, allowing the primary key to be repeated. So for a trivial example of that, if the primary key was first name, having last name as a secondary key would let you store both John Smith and Sally Smith. Otherwise, you'd get a primary key conflict error. Sort keys don't affect partitioning, so nothing to worry about there. However, sort keys do affect the order in which the records will be stored on disk, which can have implications for query speeds. That's why sort keys are sometimes called range keys. Indices in Dynamo allow searching on a field other than the primary key. Any field that's not a primary key, sort key, or index cannot be directly searched. Also worth noting, indices become their own records and take up space, so you'll want to think about that. As an example of how these keys and indices work together, imagine we're storing employee records. If we index start year and have employee ID as a primary, we'll enable a two-step process to drill down to employee records by start year. First, we'll search the start year from the index, grab all the matching employee IDs, and then query the main table for those employee IDs by primary key. Like S3, DynamoDB is designed for high durability and availability. All your data is synchronously replicated to 3 different locations within your region. You also have the option to enable cross-region replication, which asynchronously replicates your Dynamo tables to another region. AWS handles this automatically, so if there's a problem in your primary region, you need only switch your endpoint to the other, and your connected applications can fail over to the backup. Note that there is an additional charge for enabling this feature. One last capability of Dynamo I should mention is its Streams feature. Similar to event notifications in S3, Streams publish events whenever something changes in a table. You can get notifications for things like inserts, updates, and deletes on records, letting downstream systems note that a change occurred, as well as providing context, like the JSON that was just edited or deleted, making it possible to chain Dynamo with other services like Lambda or SNS to create some interesting design patterns. With that, let's head to the console and try our hand at creating and querying a simple DynamoDB table. Alright, in this demo we're going to create a DynamoDB table. I've got the service here under recently visited, but of course you can always go up here and type into the search bar and click the first option. Now before we get started, let's go to the console where I have opened the file under chapter 4 called filmdata.json. So this is in the exercise files. If you open that up, you can see that there are a number of Dynamo-ready items here that describe different movies, such as Jaws here, Memento, Eternal Sunshine of the Spotless Mind. You can scroll through this and see. Now, this is not exactly a JSON file, because if it were, this would be an array and everything would be in square brackets with commas between it. Instead, what we have are individual items here. And in a moment, we'll need to copy and paste some things into the GUI. Now, if you were using DynamoDB in a production setting, you would probably be working with an application that you're building, which would mean you'd be using some sort of programming language SDK, say for Python, and you would interact through that to talk to Dynamo, and your application would be creating these items. So what we'll do is a little bit out of the ordinary from a production scenario, but it'll work pretty well. So back to the console, we are in the DynamoDB section. Let's click Create Table. So we'll call it Film Data. And for our partition or primary key, we will enter, go back and you can look, film title, film_title. That's going to be something that appears in every item. So that makes a good primary key because it's in every item and it's evenly distributed sort of alphabetically. As to the sort key, a secondary thing that we might want to query on would be director. So we'll type that in. Keep all these performance configuration options at their default setting. No need for tags, and click Create Table. At this point, our table is creating. Should just take a second and we can refresh here to watch its progress. Okay, the table is active now, so we can click its name and go to Explore Table Items, this button here in the top right. Here we have 2 sections. We have the Scan and Query section, which we can use in a moment to query our data, or we can collapse it now. And we can see items down here in the bottom. Right now, of course, we have no items, so we'll click Create Item. Now, because we defined that partition key and sort key, we are greeted here with inputs for film title and director. So as you can see here on this little tab widget here, we're on the form view of this page, but we can also go to the JSON view. And here in the JSON view, we have another toggle which gives us even more information. So you can check and uncheck this toggle that says View DynamoDB JSON. When you're viewing DynamoDB JSON, this is literally the JSON format that Dynamo stores its data in. So you can see this looks a little bit different from your typical JSON you might expect. Instead of film title being a key and the title being a value, film title is a key that leads to a small object here, and we have S as the key and something here ready for us to type in a value. So that's what DynamoDB JSON looks like behind the scenes, and if you're working with its API or CLI, you might need to use this format. But for our purposes, we can just untoggle this and we can see something here that looks a lot more like JSON. So what we can do here is go back to the console and highlight one of our films from bracket to bracket, copy it, come over here, delete what's here, and paste in that text. Then we can click Create Item. So this is a little bit of a slow process, like I said, not normally the way that you would do it in practicality, but take a moment, go through here, and highlight each of those films and create some items in the database. Okay, now that we've got all the film titles in here, we can take a look at the Scan Query section and see a little bit of how we can interact with this data. So in our drop-down here, we have just a table name, and we can choose, oops, you can always expand that again if it collapses. We can go either scan or query the data. So scan is just kind of what it sounds like. It's a full table scan, which means that if you run it, you're going to get all the objects back, and you have the option to filter. So you can filter on any attribute of the data. I could put in here something like film title is equal to, and we'll say JAWS, and run that again, and we're going to get just that response back. But in terms of performance, it's not very good because we are pulling all the data back on the server side, pulling that all down over the network, and then filtering the results on the client side for just the thing that matches the film title that we wanted. So we can also go to query here, and we can search based on the partition key, which is the film title. So I can type something that I know exists like Star Wars, run that, and get a response back. Of course, the difference is I'm not doing a full table scan. I'm not bringing all the data of the database over a network call. That query is being executed on the server side in AWS. I can also filter on the director here. The sort key can't be queried by itself, but can be queried as a subset. So of course this will work if I type in director George Lucas. By the way, I've got two versions of the movie Psycho in here. So if I search that as the partition key, I get both, but then I can specify Alfred Hitchcock to narrow that down a little bit. So if I want to search beyond that, and I want it to happen on the server side instead of being a full table scan, then I'm going to need to create an index. So I head back to tables here on the side, click into film data, click on indexes, and create index. So here we're creating another partition key and sort key because essentially what we're doing is we're creating a copy of our data. And how extensive a copy of that we get to decide here, but we do need to start with a partition key. So here in our data, we have release year on a lot of the objects, but not all of them. That's okay. That's what an index is good for. So we type in release year there, and I'm going to leave sort key off. I'll scroll on down and keep all of the defaults here, and I want to point out attribute projections. This is where we can determine how much of a copy this index actually is. If we say all, then that means every attribute of every data record is going to get copied into this index. We can be more specific and say only certain keys, but for this demo, I'll keep it at all, and we'll click Create Index. Now that this index is being built, we can go back to the table level, click into Film Data, and click Explore Table Items again. And now under Query, we should have something new in the dropdown. Now it may take a moment for the index to appear, or we may need to refresh the page. And now we can see that the index does exist. We can click on it, and we see we have the same two options, Scan and Query. If I click Query, kind of a quirky thing, it actually skips back to the table option here, but we can reselect index, and we see we have a different thing that we can search on, this partition key based on release year. So I can type in 1991 and get back Jurassic Park. And now that query is taking place on the server side with AWS rather than pulling the full table scan down and needing for me to filter it on the client side. Okay, let's clean up our DynamoDB table. This is a pretty simple process. We're here under Dynamo, under Tables, and we'll click the checkbox next to Film Data. Click Delete, type in the word delete, have this box checked to delete all CloudWatch alarms, and no need to create a backup. Click Delete Table. That's going to take care of the table, the items, and the index.